Hello and welcome to the digital track of the Cascadia R Conference. My name is Diana Dishman. I work with NOAA Fisheries in our West Coast region, and I'm going to be sharing a bit about how we've been using R to help our regulatory team of natural resource managers work better together. So to tell you what I'm going to tell you, I'm just going to say up front that I'm going to make the argument that coding is for everyone, not just data scientists, and this includes people like myself who work on policy and resource management. Coding in a way that considers your whole team is actually going to be most helpful to you, and that you can and should design your code to get your team to collaborate better. And what I mean by that will become a little more clear by the end of this presentation. So we all work with teams, and those of you who are enthusiasts here, we all know that when you propose doing something in a new way or using a new technology, there are some responses you're likely to get from your teammates. There's usually a skeptic who might be interested, but doesn't really believe what you're proposing is going to do everything you say it will, and it's just not going to be as great as you say it might be. There's usually someone who's a little uncomfortable picking up new technology. There may be some over-enthusiasts, the people who are so excited about change for change's sake that they tend to run with your suggestions before they walk. And inevitably there's somebody who, even though they might be very capable, is just uninterested in changing the way things have always been done. So knowing that there are all kinds of different personalities on most teams, then there are a few challenges that are specific to our teams. And so we are NOAA Fisheries, and we are marine and fisheries scientists, so often people think what we do is quite glamorous or fun or interesting, and sometimes we even think that ourselves. But instead of being out in the world collecting data from beautiful locales, what we're usually doing is actually analyzing data at our desks. And in particular, our science centers do a lot of research, our regional offices apply a lot of policy. So that means in the West Coast region, we are responsible for managing a number of threatened and endangered species and making sure they are adequately protected. And we also have to make sure fisheries are sustainably managed. And we do that throughout several offices across 4 states. So that means that we are doing analyses of our species, but we are analyzing them with regard to laws. And there are many of them, including the Endangered Species Act, the Marine Mammal Protection Act, the Magnuson-Stevens Act, which is about sustainable fishing, the National Environmental Policy Act, and many more. So many regulations that govern these species, and they are part of NOAA's stewardship mandate. Are we being good stewards of our species and making sure that fisheries are sustainable for generations to come? The other parts of our mandates, though, we are a science agency, so our mandates are to have credible science and to provide service to the public. So when we analyze species with regards to the applicable laws, these policy analyses must be consistent and repeatable, which is part of doing good science, and transparent and well documented, which is part of our public service. So while these are policy analyses, these characteristics should sound very familiar to any analysis you've ever done, and they have these things in common with quantitative analyses. And one last consideration about working with teams within the government or agencies of natural resource managers is that we often are notorious for problems with siloing, where individuals will be siloed off in their geography or focused on their species or project, and their processes become increasingly individualized and less consistent or aware of what else is going on across the region. For example, within our evaluations of whether or not a research project might impact our threatened or endangered species, let's say an applicant comes in, like Emily here. She is another presenter at this conference and is a researcher with the Alaska Fisheries Science Center. And if she submits an application to our 4 different offices for the same project, in our siloed environment, it's very possible for each analyst in a different office to approach that analysis and ESA implementation in a slightly different way. All of these methods might be valid, they might all be defensible, they just come with different assumptions, but the result can be different outcomes. One office might say yes, one office might say no, one office might say you can do parts of this, and others might say we're not sure of the impact, so those outcomes could be inconsistent. Another inconsistency we saw was with timing. So even if our offices had similar conclusions about whether or not a research project could be allowed, we might have totally different timelines for how long that analysis took. So one office might be able to get a permit within a few months, while another would take 6 months or even over a year, which makes it very difficult for researchers to plan their field seasons. The response to such an inconsistency is pretty easy to predict. So when you expand this to the other kinds of regulatory decisions that NOAA Fisheries has to make, that includes consulting on whether or not several kinds of actions can go forward as they're proposed, transportation projects, dredging, construction, whether these things need to be modified, and then whether or not we list a species as threatened or endangered, when we come up with a recovery plan and the criteria for what it means for a species to be recovered, and with our fishing regulations, what are the catch limits going to be? What's the season and the gear restriction going to look like? And then how do we, in real time, manage those fisheries to reduce risks to other species? So we have to make many kinds of decisions in the same way over and over again as data and conditions change. So these kinds of regulatory decisions require the same rigor that we typically think of using code to apply to our analytical processes. So what do you do? The temptation of many of us who know how to write code, when we identify tasks that are repetitive, is to automate them. We jump to code, we say, I know how it can solve these problems with consistency and repeatability and transparency, so I'm going to code my task. So if I'm the person on the red line, I'm going to do something a few times, see that I can automate it, I'm going to write a script, and then from that point on, I can always crank out a script that's going to give me consistent decisions. Whereas other members of my team are going to keep doing something manually, and maybe it will take them longer, or it'll take them longer every time, or they might not get the same decision every time, but you know what? That's their problem. At least I know I'm doing it the right way. So our impulse is to just go there and fix the problem for ourselves, knowing that we are in the right. What I will argue is that that's only the first step. If you are really good at doing your job and really efficient with your work, what happens is usually you just get assigned more of the work. So you aren't really doing yourself any favors if you're only thinking about efficiency for your own processes when you work on a team. So a better way to work through this, and the approach that our team adopted, is to design a process that includes everyone and includes input from everyone, regardless of their relationship to the code. So you're not going to make yourselves a team of coders. Not everyone's going to learn R, but you can design a process that includes everybody. So our team has some code builders, like myself, who may write new tools and pieces of code. Then we have some code users, people who are comfortable with R and can open a script that's been written already and run it, or maybe feed it updated data. And then we have output users who are not comfortable coding necessarily, but they know what the code does. We've discussed with them its assumptions and its rules, so they know how to interpret the output it creates, and they can all give feedback to the process. So instead of thinking of ourselves like two groups of people with two different trajectories who are working on the same types of projects, we are now one team, and while some of us might be on the orange line here where we are coders who build code and write code, then we also have our team members on the green line. They are still part of the process. They see our opportunities to automate, they learn how to use scripts and their outputs, and they help us identify more opportunities for automation because we've made them aware of what R can do and what automation can do. And once they have that awareness, they bring more and more tools into the system, and we keep iterating. So over time, everybody is gaining those efficiencies, and everybody is adding and deploying more tools across our team. So under our new approach, Now, if somebody submits an application to our database, we then process that data with R to create calculations and screening tools that everybody uses. And those numbers get deployed to everyone on our team. So we're all looking at the same thing. So the team thought this was going to be great. It's going to save us time because we're not all doing the calculations. I will fully admit, I thought the goal was simply to save time and make us more consistent and reproducible. I did not anticipate that we would have other benefits. We enhanced the QA of these products because we found errors we didn't know were there. We ended up sharing drafting of the documents that these went into, and the roles on our team actually became interchangeable. So we didn't see that coming, but because of how the code was designed, the workflow changed, and now what used to be done independently in separate offices was done as one shared product. So we all created components of a single draft document, and we could all jump in and take over each other's parts of that document if somebody wasn't available. So instead of looking like it did before with one line of information going to each of the analysts in each siloed office, now there's this network of interaction between us where we're talking to the applicants but also to each other about how to interpret this information. And we realized that was a design of the code. So by enforcing this process where one set of code creates screening tools that everybody sees and syncing that up, and then requiring a step where everybody is in agreement about the conclusion before the process can move forward, before our next piece of script can be implemented, that actually enforced everybody to have an equivalent role in the team and to share work. And it made us realize too that you should think about how you want your team to interact with certain documents and certain products to get them to behave in certain ways. So for example, if there are certain things about our documentation that were assumptions I want to codify in the record, I don't necessarily want that to be beholden to other members of my team. So I might code R to produce something without intermediate steps that goes directly to product. But if I want to encourage my team to collaborate, to discuss, to debate at particular steps, that's how I design my stepwise process, and that's how I modularize my code and my products to get the workflow and the team flow that I want. As we apply these kinds of approaches to different types of policy decisions that we make across the region, we're getting stronger stewardship because we know we're getting more consistent analyses and application of the different regulations as we share information and plan more intentionally what is the role of our different partners going to be in this process, when are we going to get their input, and our code can help frame that out in a way where everyone will see and understand the result. To sum up, in case this was too long and you didn't read, for our team, we recognize that policy analyses require the same rigor as quantitative analyses, so we should be coding them and not forgetting about them in terms of our consistency needs. We also recognize that code organization shaped the workflow and how our team worked together to get a task done. So seeing how it changed people's perceptions of who owned the code, how the work was shared, we're all driven by code design. Now we know to start with this in mind. If you think ahead of time about how you want each member of your team to interact with your code and its outputs, you can help shift how your team collaborates over time. So for any team, these lessons can apply. Coding is for everyone on your team, not just the data scientists. Code with your team in mind, for your team, to ultimately help yourself. And you can and should design your code in this way to help your team collaborate better. Because then your team is happy, and you are happy. Thanks very much. I look forward to talking with all of you tomorrow at our conference.